All right, let's stand for the pledge. I pledge allegiance of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, a couple quick notes before we get started. It's Monday. Hopefully you guys had a restful weekend, ready to go for a whole week. All right. Interesting.
I almost made planning on cake, so I called food.
Okay, listen up, please. So we have, in this class, we only have one person needs to take the test. They're going to take it tomorrow. In my other 7th period class, I never hand out tests until everyone has taken the test. I also have a couple e-learners that haven't taken their test. Long story short, yours is all graded. They're in a grade book. As a class, we did okay. A couple people didn't do so hot, but as a class, I want to say this class had 6 people that got perfect papers. I think in my other class it was 8. This was, you guys were 2. It's either 6 or 8 or 5 and 7, one of the 2. Anyway, we did as a class, we did okay. Obviously, those who got a perfect paper did outstanding. If you did poorly on the test, and by poorly I mean it's C's or lower, and you're like, I should have gotten a much higher grade. Remember, I offer retakes of any quiz or test that you do poorly on. If you got a B+ and you're angry because I'm an A student, I don't give a retake for that. But absolutely, if you got a C or lower, I'll give you a retake. And even some low B's. Even if it's a low B, we can talk about it. I would encourage you to make sure you're checking your grades, maybe not daily, but at least a couple times during the week. One, to make sure you understand what you're passing, right? Understand what you probably need to do more studying on. And then lastly, in case I make a silly mistake, I have been known, not on purpose, but I have been known sometimes to enter in a wrong grade now and then. You guys know what your grades are. Homework is always out of 10 points. If you do it, you get 10 points. But sometimes on a quiz, I'm human, I can make a mistake. When you get your quiz back, you're like, hey, I got a 98, you put an 18. You know, I have no idea why, maybe because I lost my brain there for a second. But make sure you're checking your grades. If your parents have not given you the password to PowerSchool, ask them, right? Hopefully they say yes. And as an upper school student, you should be checking all of your grades. And that way there are no surprises, especially as we get closer towards, hey, we only got about a couple more weeks and it's the end of the quarter. And we're starting chapter 3 today. So I usually get through about 3 to 4 chapters per quarter, and we're already starting chapter 3. So we're getting close towards the end of the quarter. Okay, speech over. No, I'm not gonna give you your test simply because I just don't want tests floating around when there's other students. I change my test every year, but I don't like a graded test to be out while I have other students have not taken their test, not because I don't trust you, but because I don't trust you, if that makes sense. All right. Hey, look at the board. What do we got going on this week?
Nothing.
Well, just a normal math class. No test, no quiz. Quiz next Monday. All right, copy down your homework.
Yours an exclusive invisible ink. Carbonated water.
No, somebody's got some nice smelling coffee.
That's probably her. Give me a coffee.
There's no way that
Carbonated water. Black cherry coffee. Carbonated water.
it's a lotion? It smells like coffee. Okay, that's exactly why.
Yep.
Now I'm thirsty.
Oh, it smells so good. I got so many gifts.
Okay, you guys can do this without making too much noise. We are moving on to a chapter. The chapter is entitled Decimals. We're not doing decimals. It says right here, it says note, evaluate means to simplify, right? Even though evaluate means plug in numbers and simplify, Just a quick reminder. It'll make sense when you do your homework. Now, $1 to $28 is a lot. That must mean these are pretty quickly done. I do not give an hour's worth of math homework, not for 7th grade. So this isn't an hour's worth of homework. This is pretty quickly done. As I said, the chapter is entitled Decimals. We're not doing decimals today. They're kind of shoehorning this concept in before we get to decimals. Thank you, thank you, thank you. All right, here we go. So it's called Exponents and Powers of 10. Yeah, and the reason why they throw this one in here is because we talk about powers of 10. We're also going to, it's going to segue into the place or place values, which are, you know, if you don't know it, we have a base 10 number system, right? Okay, so something new today. Some of you may have seen this before, others you have not. But here's the idea. Hey, what do we got going on here? It looks like we got what number being repeatedly multiplied by itself?
2 with the power of 7.
2 times 2 times 2 times 2 times 2 times 2. That's a lot of 2s. Well, let's see if we can do this. Mathematically, how would we calculate the answer here?
2 times 7.
Well, we got to use,
Well, I don't know the version, but I can still.
yeah, but how would we do it? Tell me. Can we do these two first, or we got to go left to right, or it's commutative, we can do them in any order we want?
Yeah, I know.
It's commutative, we can, as long as it's multiplication, we can do them in any order we want. PEMDAS says all multiplication division is done left to right. It's your choice. Okay? So by PEMDAS, if we go left to right, let's see, 2 times 2 is
4, 8, 16, 22, 32,
64, right? We get to 64. Mathematicians are lazy, right? So we don't say this, although I say it all the time. Mathematicians would say we're not lazy, we are efficient. So mathematicians do not want to write this.
Yes, sir.
Oh, by the way, calculations, you have to do that.
Yes, sir.
But mathematicians don't want to write that mess. 2 times 2 times 2 times 2 times 2 times 2 times 2. It just seems like too much work, pun intended, right? So they've developed a way, right? It's a shorthand way of writing this, okay? By PEMDAS, we'll notice we haven't done anything with this letter E. That's kind of where we're going today. So remember that, oh, this isn't multiplication. This is, you learned in 2nd, 3rd, or maybe 4th grade, hopefully before the 4th grade, that this can be written as 2 times, that is because repeated addition can be written as multiplication, right? Multiplication is basically addition. It's an efficient way, more efficient of writing. In fact, it's so efficient, we made you memorize the answer to this. No one actually does 2 plus 2 plus 2 plus 2 plus 2. Nobody does that. They do 2 times 5, and your brain says the answer is 10. Okay? We're going to do the same thing for multiplication. The same thing we're going to do for multiplication. In fact, we're going to once again make you memorize the answers. Okay? So be ready for it. All right, write this down, please, box 1. Write this down, please, box 1. Exponents. That's what the E in PEMDAS means. Exponent, it's simply a way of showing repeated multiplication. Just like multiplication is a way of showing repeated addition, exponents are a way to show repeated multiplication. Question, Gavin?
Oh, you forgot to take attendance and
I did.
and hot lunch.
I did. Thank you. Exponents, a method of showing repeated multiplication. All right. Here is what it looks like. We know what multiplication looks like. Here's what repeated multiplication looks like. Notice we got a big number and we got a small number. I'm not talking about values. I'm talking about its physical size. You see, you got a big number, and then above it to the right, it's important where it goes. You will eventually learn that there are 4 positions that the little number can go. It can go in the upper right, upper left, lower right. At least through high school, you will see 3 of these positions. I think chemistry actually uses all 4, if I'm not mistaken. So if you add math into Science, you'll eventually see a small number appear in all four positions. For math and for science as well, too. If it's in the upper right, that's called an exponent. Okay, we got two names. We got to need a name for the big number. We need a name for the small number.
Big Jimmy, little Jimmy.
All right, we're going to call the big number the base. And remember, when I say big, I don't mean value, because obviously 3 is bigger than 2. But we're talking about physical size. Write this down, box 1. Write this. Big number 2, small number upper right 3. The big number is called the base. It represents the number that's being repeatedly multiplied. In my example, 2 times 2 times 2 times 2 times 2. The big number is that number that's being repeatedly multiplied. Yes?
Yes.
All right, take a guess what the 3 means.
Exponent.
Take a guess of what it means. Doesn't mean multiplication. What does it mean?
It means how many times that number.
How many times you write the big number, the base, right? You are correct in calling it its name. You guys apparently already know its name. What's its name? It's called the exponent or the power. But it's, as she's correctly stated, she said it's how many times you write the base. Guess what it doesn't mean? Guess what it doesn't mean? It doesn't mean 2 times 3. It does not mean 2 times 3. There are like 2 cases where it does, but there are exceptions. It doesn't mean 2 times 3. 1 to the first power is 1, and 2 to the second power is in fact 4. But those are, and well, yeah, those are the only 2 off the top of my head. All right. Okay, so this means write the base 3 times, 1, 2, 3, and you said it's supposed to show repeated multiplication, so we put dots in between. That's how you do the math. We will talk about the answer in a few slides, but for right now, we're going to look at these 2 constructions. We're going to look at this construction, and we're going to look at this construction. They both have names, like what is this thing called and what is this thing called, okay? We'll describe those. Those are the first 2 things you have to do in homework.
The number.
We okay so far?
Yes.
Okay. Oh, show of hands how many people have done this. Okay, good. We'll go quickly. All right. 2 times 2 times 2 obviously is not 6. It's 8. All right. So here's some quick examples. The big number here is, and I don't mean like the number that's the largest number. I mean literally physically the biggest number. Size-wise, 13 is bigger than this little tiny 3. So the big number is called the base. That's the number that's repeatedly multiplied. How many times do I write 13? I write 13 3 times. 1, 2, 3. Put dots in between. Right? We'll talk about the answer later, but for right now, we're just talking about this construction and this construction. Okay? I'll give them names here in a second. How many times do I write 13? You guys, some of you are 13.
That's me.
Guess what? You're really 13 to the first power. We choose not to put the 1 there because we're lazy. I mean, we're efficient, right? But all of you right now, or whatever your age is, to the first power. We just choose not to write that 1. Okay? How many times am I writing 13? 2 times. And my claim is that you are going to memorize. Where's my, there we go. 1, 2. My claim is that you are going to memorize these answers. Remember doing your multiplication tables? You are going to memorize the answers to these. Obviously, that one doesn't require much memorization. This one certainly does, and so does this one. Okay? No, I'm not going to make you memorize like you did in 3rd or 4th grade, like you spent months with flashcards. But we will memorize a few of these this year and next year. Yes?
Can we get an exponent table?
You know, that's a good idea. I'm going to make you make one.
I came up with it. It's my
Okay.
idea.
Now, when we get to that particular part, we are actually going to make one. Okay, so now we got to talk about these names of these constructions. You see what's in yellow? We call it expanded form. It kind of makes sense. You take the exponents, right, or the base and its exponent, and you expand it out so that you can get to an answer. Does that make sense? So this is called expanded form. Tonight for homework, they're going to say, write the number in expanded form. They're not asking you what 13 times 13 times 13 is. They're just asking you to write the number as repeated multiplication. Anybody lost on that concept?
No.
Hard or easy?
Easy.
Well, that's pretty easy. As long as you can count 1, 2, 3. 1, 1, 2. Okay? All right, so let's see. 3 to the, let's see, how do we even say this?
3 times 3.
What?
3 to the power 2. Oh, I was
Okay.
going to say
Is that the only way to say it?
3 to the second power.
Is that the only way to say it?
3 times 3 times 3.
Is that the only way to say it?
3.
You almost got them all done.
3 of the exponent of 2.
We could, but there's one other way I'm looking to say this one.
3 to the power 3.
It will never, and it's not 3 plus 3.
3 to the power 2.
That's what somebody said over there. All right, enough of that. So if we ask you to expand this, right? Well, let's see. We go to the base. The base is 3. We write it 2 times, right? So to expand it, the base is 3. We write it 2 times. 3 times 3 is 9. When it asks you, and this was that note at the start, when it asks you to simplify, it's asking for the actual answer. So if it says write in expanded form, done. If it asks you to simplify, they're asking for the answer. What's the answer here? The answer here is 9. Okay. So the process of simplifying includes, because you don't have these memorized yet, write this in expanded form. Now, some of you might be able to do that one in your head. Others of you, 3 to the 5th power, you don't have that memorized. And no, most of you can't do 3 times 3 times 3 times 3 times 3 in your head. So you will be required to write it in expanded form and use PEMDAS to get to the answer. Okay? All right, so let's expand and simplify these. Here we go. Box number 2. The first one, you don't have it memorized. This is 3 to what power?
3 to the power 3.
Right, so this is not 3 times 3.
27.
3 times 3 is 9, but this one, when we expand it, 3 written 3 times.
27.
3 times 3 is 9, times another 3 is 27. Once again, it's not 3 times 3, it's 3 written 3 times. Okay, the second one you can do in your head. What's the answer? 54. This one you should be able to, because it's one of your multiplication tables. This is 12 written how many times? So therefore the answer is, all right, that one doesn't require you to probably expand it to get to the answer. But the first one does and the last one do. All right, last one, this is what written how many times? 4 written 3 times. Let's see, 4 times 4 is what?
16.
16. And most of you don't know 16 times 4 memorized, but it is 64. So of the 4 problems here, the first one, the last one, do require some scratch work. Now, not this week, but 2 years from now, you will at least have the last one memorized because you're going to see it often. 4 to the 3rd power, oh, that's 64. Just like 8 times 7, it took you, I don't know, a month or 2 to memorize. That's 56. It will take you a year or 2 to memorize 4 to the 3rd. So we're not going to, like I said, have a multiplication table / exponent table, flashcard thing. But we will see some of these. I will make you memorize some of them, but not that one. This one, the same thing. You'll probably have this one memorized this year because you'll see 3 to the 3rd power enough that you'll say, oh, that's just 27. What's up?
It's 243.
What is?
3 to the 5th power.
Good job. All right. So do box 3 all by yourself. Do box 3 all by yourself. Anybody need help? We are all here today. All right, before I screw this up, let's do hot lunch right now. All right, if I point to you, you're good to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm supposed to have a sheet. It wasn't in my mailbox. What?
My parents can't find the menu for the tree at the D49 app.
I know it's right up there.
Like the actual menu on the D49 app.
I will send an email to admin about that. What's up, Ace?
At the beginning of the year, you caught me with my head down and he said, "Oh, I don't care if he has an A, he could have his head down. So can I put my head down?"
You didn't get an A on the test.
Okay.
In fact, given your prior performance, I was a little disappointed with you on the test as well.
Yeah.
He got an A on his history test for somehow.
Somehow?
I got a B and I still got to choose my C.
All
I
right.
got a B and I still got to choose my
Here we go. First one in the back. What'd you get? I got 8 as well too. Very good. 2 times 2. This is one of the ones that you'll multiply. Guess what the answer is not?
6.
It is not 6.
12.
I will see 6 on some people's tests. This typically happens when you stop thinking. You stop thinking, you're like, oh, it's just 2. No, it's 2 written 3 times. The second one, the answer is 100. And the third one, the answer is on the
You
back.
put 10 on the board.
I didn't put 10, I put 100.
Hey. Nice try.
And the last one,
100.
125. These are, well, this one you already have memorized. The first one and the last one you don't have memorized. These are common ones that you will have memorized. 5 to the third power, 125. 2 to the third power is an 8. Okay. A few quick notes. In fact, I want you to write this down in box 4. Don't do this, right?
Don't do what?
Guess what I'm about to write?
8.
Don't do this, right? Circle that. Put arrows or something. I don't know. Don't do that.
That's what I
Right?
checked my.
It's not 4 times 2. It's 4 written twice. Don't do that. Right? It's 4 times 4, which is 16 is the right answer. Don't do this. The answer is not 10. This is probably the most one. I don't know why, but if there's a mistake, this is, I see this in high school, right? 5 to the second power and someone will write 10. My belief is when you stop thinking, you turn your brain off for half a second and then 5 to the second power all of a sudden turns into 10. Even though everyone knows what to do correct. All right, 5 to the second power is actually 25. Okay, maybe I created the monster by showing you this slide, right? Maybe I'm the one that makes the problem. I don't know, but I just know that I see these 2 mistakes here enough. 2 to the third power would be like the third one that I see the most. People want to write 6 for some reason. Okay, don't multiply the base times the power. Yes, there's 2 exceptions, but there are exceptions. All right, box 5, I need you to write this down, please. All right, any base to the second power, this was the question earlier, you got them all but one. Somebody said 4 to the power 2. Somebody said 4 to the second power. The one that we were missing is no one? Right? You guys remember geometry?
No.
Yes.
If I were to draw a square and said that this side is 4, what's the area of the square?
16.
Why? Because you multiply 4 times length times width or base times height, right?
Yeah.
This is why we call 4 or any base to the second power also. What's the shape? That is why we call anything to the second power also 4 squared. For this reason right here. Because it represents the area of a square. I don't know who came up with this, but more times than not, we don't say 4 to the second power, we say 4 squared. For me, this was a really hard thing to get used to. If there was only 4 squared, we'd be good, but there's another one.
Yeah.
The next one involves, take a guess,
Circles.
4 to the third power. Okay, watch the magic. What am I making?
It's a cube.
A triangle.
You may or may not have been exposed to this. What's the volume of a cube? Length times width times height. So in other words, 4 times 4 times 4, hey, that's 4 to the third power. So guess what we also call anything to the power 3? We call it 4 cubed. These two things, until I got, I don't know, probably sophomore year high school, the teacher would say 4 to the 4 cubed, and I would stop and I was like, I don't remember which one that is, to the second or the third power. It didn't stick with me until middle of high school. For you, I'm starting you off in 7th grade. Hopefully you aren't as bad as me. Teachers, and most math teachers won't say to the second or third power, they'll say 4 squared, 4 cubed. You're expected to hear that and be able to, oh, it's 4 to the third power. Oh, it's 4 to the second power. Me as a teacher, because I know some students also have the same problem, I always say it both ways, at least until geometry, and then I stop. Yes?
Why do we divide, well, this is an odd question. Why do we divide circles by pi to get their?
We will talk about that when we get to circles. But it is a good question. All right. So we good on this? Do you have that written down in box 5? You're going to hear me say 4 squared. But then I'll immediately say, oh, that's 4 to the second power. Or I'll say 4 squared or 4 to the second power. At least until geometry. All right. Oh, what's that?
Where's the ninth power of 9?
Okay. So once it gets higher than to the third power, right, then we add a th next to the number. So this is 4 to the 9 th power, right? So anything higher than to the third power, we say the number with a th. So 4 to the 10th, 4 to the 8th, 4 to the 5th, 4 to the 16th, 4 to the 1000th. You're like, isn't that the same way we say decimals? Yeah, sort of, kind of. We'll talk about things to the 0 power, but not right now. Because we do have that. In fact, that's what my clock says. Yes?
What if you had a decimal?
We do, and you won't see that until Algebra 2. So we do have such a thing. And in fact, it's such a weird concept. I don't even want to jump into it right now. But we have decimal. We also have fractions as well, too. Right? But we won't see that to Algebra 2. Yes? I don't teach Algebra 2. Mrs. Newburn does. At least for this year. Next year, maybe I teach it. Every year changes what I teach. Okay. So it goes, what the course you're in right now, the next year it's pre-algebra. It's also called course 2. And then it goes algebra 1, geometry, algebra 2, pre-calculus, calculus. Those are the.
Calculus and calculus.
I'll describe it, but not today. Yes. You do at this school, sure. All right, now we're going to change, and you probably have forgotten what we just did, but we're going to reverse the process, right? Now I'm going to give you expanded form and ask you to write in.
Easy exponential.
Okay, we haven't written that down, but the first form is called the exponential form. All right, sit up straight in your seat, please. Thank you. All right, so exponential form is, well, it's the form that you start with. All right, here's how it's done. Step number 1, you look at the numbers. What number is being repeatedly multiplied?
4.
So 4 is your base. Then you do the monkey method. You take your finger, you simply count 4s. 1, 2, 3, 4, 5. Therefore, this is 4 to the 5th power. So this is called expanded form. The base is 4. So 4 is the large number. We count how many 4s. There are 5 of them. So 4 to the 5th power. Easy or hard?
Easy.
Don't make a mistake on this, right? You're just counting numbers. All right. Expanded form, exponential form. Those words, maybe this is the first time you've ever seen them, right? They're not that challenging, but you can, I mean, it's got a lot of E's and X's and P's in it, right? So make sure if you need to have that written in your notes, write that in your notes. Wait, which one was exponential form? Is that the one where it's all the numbers being multiplied, or is that the one with the base of the power?
Base and power.
Okay. All right, what's being repeatedly multiplied?
5.
How many 5s are there? So what's the answer in exponential form? 5 to the power of 3 would say 5
Cubed.
5 cubed, or 5 to the third power. Those are the three ways that we would say it. 5 to the third power, 5 to the power of 3, 5 cubes. Okay? Ooh, lots of numbers. Make sure you don't. So clearly what's being repeatedly multiplied here is
12.
7.
7 by the power of
1,
6.
2, 3, 4, 5, 6. Therefore,
It's 7.
7 to the 6. Heads up. Heads up. Sit up.
With why?
Actually, I wasn't talking to you.
Yeah.
Someone else. All right, we got this?
Yeah.
Okay. So do box 6, please. All by your lonesome. All by yourself. We want to write it in exponential form. Is everybody clear on what I want you to do? Okay. Remember, you can always get started on homework.
Wait, right now, this is really the last thing we have to do.
Well, what else is left on this paper?
The
The
backside.
backside.
Why are there X's instead of dots?
Well, just remember, in our book, in course 1, they don't get rid of the X's. In fact, you'll still see the X's in the first 2 chapters of course 2 book. And then after that, no more X's except for scientific notation. Yes?
Is it possible to have a is it possible to multiply a variable? Is it possible to like square or cube a variable?
Absolutely, 100%. It is possible. In fact, we will do it this year. Just not today. His question was, can we take a variable to a power? And the answer is absolutely yes. In fact, that's what most of algebra and algebra 2 and pre-calculus and calculus is about. Variables to powers. X to the third power. X to the second power. In fact, they make shapes when you do this. Geometric shapes, if they're written as an equation. All right, we good? All right, let's do the front of the room. First one, go, David.
It is 6 to the power of 3.
6 to the power of
6.
6 to the power of 6. 6 to the 6th power.
6 to the 6.
All right, next.
11
Go.
to the power.
We were in the front row. Go. 11 to the third power or 11 cubed. Either one will work. And the last one,
4 to the
Jameson.
4 to the power of 5. 4 to the power of 5.
4 to the 5th power. 4 to the power of 5. And those are the 2 ways to say it. All right, we good? All right, last idea of the day. Right, it's not really a math trick. There are no math tricks. But have you ever noticed, right, math tricks, I say, are things that allow you to do the math a little bit easier, a little bit more friendlier, quicker, that sort of idea, okay? But we're not really doing a trick here. Have you ever noticed that when you multiply 10 times 10, you get?
100.
Anybody notice the power here? Well, that would be 10 squared, and that's 100. Have you ever noticed that you multiply 10 times 10 times 10, you get? Well, that would be 10 to the third power, that's 1,000. Have you ever noticed that we do 10 times 10 times 10 times 10, we would get?
10 million.
Well, that would be 10 to the, that would not be a million, that would be 10,000. What is the pattern I'm trying to show you here?
They're
Adding zeros.
All right, so Jaden said, look at the first one, it has how many zeros?
6.
The starting off problem has how many zeros? Ace, please stop. And the answer has,
2.
now the exponential one does not have 2 zeros. But the expanded form and the answer, the simplified form, has 2 zeros. Well, what about 10 times 10 times 10? How many zeros? What does the answer have?
3.
What is the last one? How many zeros? 1, 2,
4.
3, 4. 1, 2, 3, 4. Now, wait a minute. Why did I write this middle step? Because what's that number right there? I'm pointing to the power, you learners. What's this number?
2.
How many zeros did the answer have?
2.
What's that number?
3.
How many zeros did it have?
3.
That's the pattern. So this is not a math trick. This is just pointing out the obvious. That when you're multiplying 10, the power tells you how many zeros. So if I were to write a shortcut rule, right? If it's 10 to a power, what's the shortcut rule going to say for the answer? How do you go from exponential form to the simplified form very quickly? What do you think you should do? Okay, so if I were to take 10 to the 7th power, what would you do? Oh, there's 7 of them. What do I do? To go from exponential form to the answer. Because I'm going to give you 10 to the 21st. What's the answer?
Oh, that's
Let him answer.
So you just do 1 and 0.
That's the shortcut method right there. You got it? 10 to any power is a 1 with that many zeros. 2, I'm pointing at. 10 to any power is a 1 with 3. 10 to any power is a 1 with 4. You see how quickly that can be done? So 10 to the 21st power, it's a pretty big number, is a 1 with 21 zeros.
That's at least 7.
Clearly.
Yeah, at least. Maybe 8.
All right. So you guys notice that the number in the exponent is also the number of zeros, and that's the pattern. That's the pattern. You okay? All right. So if you need to write this down, write this down. If all of a sudden you heard that once and you sticks with you, like it did with me the first time I heard it, I was like, oh, that's easy. I didn't need to write it down because it immediately stuck in my brain, but I gave you about 7 to write it down if you need to. When multiplying numbers that start with 1 and only have zeros, the product will be followed by how many zeros you have. Notice this doesn't say 10. This says numbers that start with a 1. So I'm saying this not only applies to 10, it applies to 100 and 1,000 and 10,000, a million. If you're just multiplying numbers that involve a 1 and a bunch of zeros, you write 1 and you count zeros. If it's 10 to a power, then yeah, the power is the number of zeros. And for some of you, this might be a little confusing, so we better do some examples, like the next 2 boxes.
Oh, I found it out. It's 1 sextillion.
One what?
1 sextillion.
Sextillion?
It goes million, billion, trillion, quadrillion, septillion,
I think Google.
sextillion.
Interesting note that was only in America. If you go to England, their billion and our billion is not the same. So if they say a billion in England, it doesn't mean the same as our billion.
What is it?
So you have to be careful. So have you ever wondered why it goes, let's see, tens, hundreds, thousands, 10,000s, 100,000, millions, 10 millions, 100 millions, and then we jump to billion? England doesn't. They have 1,000 million, 10,000 million, 100,000 million before they get to billion. Their billion is our trillion. Don't ask me what their trillion is, I'm not sure. But I just know that there's an English billion and an American billion. All right, back up here.
What's the English?
So notice, this is what this is saying. It's not saying 10 to a power. It's saying, hey, whenever you're multiplying any numbers that involve 1 and zeros and only 1 and zeros, you don't need to do the math. You simply need to count.
The zeros.
How many zeros are here?
4.
How many zeros do you see?
4.
I see 4 zeros. So the answer will be a 1 with 4 zeros. 1, 2, 3, 4. That's 10,000. Okay. How many zeros do you see?
6.
Oh.
Therefore, it will be a 1 followed by.
6 zeros.
So this is actually.
100,000.
A million.
Oh, let's see what it is. Let's see. 1, 2, 3, 1, 2. Oh, this is a million. 10 to the 6th power is a million. Million is a lot. All right. Depending upon the things that you're counting. If you're talking about skin cells and dust, a million is a small number. Take a deep breath. Guess what you're breathing?
Air.
And skin cells.
Ah.
Supposedly, a
Dust.
large percentage of dust is skin cells.
Yeah.
All right.
And dead like.
I need a respirator.
All right. When simplifying, box 8, when simplifying exponents with a base of 10, this is just the second thought here. So you have 10 to a power. Once again, it's 1 followed by whatever that exponent is, that's how many zeros. 10 to the 3rd power is a 1 with 3 zeros. That's 1,000. 10 to the 5th power is a 1 with 5 zeros. That is 100,000. I didn't put the comma there. All right, so those two statements, 10 to a power, and anytime you're multiplying 10, 100, 1,000, 10,000, so forth and so on, times another number that has a 1 and a bunch of zeros. You just write 1 and you count zeros. Or you write 1 and you look at the exponent, and that's how many zeros you write. Who's confused? Right? This is, it's not, officially you've never seen a math book. Hey, look at this math trick. It's simply an idea that saves some time. Save some time. All right, last box for sure this time. Give me all the answers. It should take you all of 15 seconds to do this math.
Yes.
15 seconds.
14, 13, 12, 11,
I just did both.
10,
Wait.
9,
Ah, no, that's not good. I'm good.
8, 7,
Done.
6 and a half.
All right.
4, 4 and a half. 3, 3 and a
You
half.
can't change the units mid-countdown.
2 and a half.
Yeah.
One and a half.
All right, first one. This is a 1 with how many zeros?
Two.
Okay, that's 100. This is a 1 with how many zeros?
6.
Okay, you got the idea? This is a 1 with how many zeros? It's on your paper, count.
5.
Let him talk.
5.
And the last one?
6. No, 4.
Right, you got the idea? Pretty easy, right? So all of these are fairly simple if you remember the rule. The nice thing is the rule was simple. It's not too complicated. Who's done their homework? No one?
I'm done. I'm totally done.
All right. That's it for today. Oh, I did have a box 10, but apparently I skipped it. So as a class, here we go.
No.
This is a 1 with how many zeros? Okay, what's that number, by the way? That's 1,000. This is a 1 with,
4.
that is 10,000. This is a 1 with,
6, 0.
that is, it's 1,000,000.
We have that box in our page.
And this is a 1 with,
10,
and that we already said was, hey, look, bookends, first and last. There we go. All right.
We have this one.
In the remaining 12 minutes of class, get your books open, get started on your homework, look it all over to make sure there's nothing you don't understand. Wait, did I say that right? Make sure there is nothing that you do not understand fully. If it's something you don't understand fully, ask a question. Yes. Share with the person next to you. Yes. Yes. Yes.
When people are counting down, they always go like 2, 2.5.
Not NASA, baby.
But they're going up.
no,
Yes.
no.
Then you go 2, and then 2.
I've never heard anyone do that. I hear to hear what Gavin did. 5, 4.5,
No.
4 and a
that's not what he said.
third.
That's not what he said. He said 2.5.
Yeah,
Yeah, he did 2.
Well, if he was counting up, we could actually play the video and let's see.
Okay, actually, yeah.
Right.
I want to hear it.
All right, e-learners, if you have any questions, hey, as a quick note, make sure that you, e-learners, I still have a couple e-learners have not taken their test. It is on the assignments tab of Microsoft Teams. Make sure you have taken your test. If you have, good job. I'll have it graded sometime this week. Check back with me if you have any questions on that. If not, I will see you tomorrow.